close, starting with this one.
Okay, so welcome to the DataLad tutorial. Quick introduction. My name is Ole. I'm a neuroscientist by training, and currently I work as a consultant for software in research, in neuroscience research at the University of Bonn. And I have been using DataLad in my own research projects for a number of years. And with me is Michal. He's also a neuroscientist by training, and he is part of the DataLad development team at the Jülich Research Center. So in a moment, he'll give you an introduction to DataLad, but just before that, I wanted to point you to the website for this tutorial. So you'll find it at this link. There's also a QR code, and this contains installation instructions. So if you go to the website, you should see this home screen, and in here you'll see the installation instructions. It's pretty straightforward. So you'll need Git, and then you just have to install a few pip packages with whatever environment manager you prefer. It's actually also possible to install DataLad system-wide, but I think for the purpose of this tutorial, using a virtual environment is a good idea. And then also there's two Python packages to install. They're not related to DataLad. It's just at some point we're going to run some Python scripts, and those rely on those packages. And then you should be all good to go. And then you can take it with the. Do I have to exit here? Yeah.
Right, so my first task for today would be to tell you about the what and why of DataLad. And I have to start answering the question, what is DataLad, by saying that it is a community project. So it has been going on already for 10 years, so much longer than since I have joined the project. And in this year's or last year's ERC conference, we had a nice poster looking back at the history of the project in terms of the project dynamics. It is really a community project in that it has attracted more than 100 contributors if you are counting across the core software, extension packages, and the documentation in the DataLad handbook. It was started by Michael Hanke, who is now in the Psychoinformatics lab at Forschungszentrum Jülich, so that's where I work, and by Jaroslav Halchenko, who is now at the Center for Open Neuroscience, Dartmouth College, and they are both still with the project. And DataLad owes a huge amount to Git Annex. It is a project started by Joey Hess, again open source, so Joey Hess and contributors. The most simple answer I can give to the question of what is DataLad is that it is a piece of software. So it is just a piece of software. It's not a service, it's not a place, it is a piece of software for data management. It is written in Python. It is based on Git and Git Annex, which is used for a lot of operations while adding its own routines on top of them. And it's free and open source, it's MIT licensed. Now more to the question of why of DataLad, and I think the main vision is that of reproducibility. So you have some data, you have some code, you run the code on the data, you get some sort of result. So the first thing that DataLad wants to give you is a dataset. A dataset would be a core concept throughout the tutorial, and it is a core concept for DataLad. For reproducibility, you would start with your own directory with some contents, and you can organize it in any way you like. If you follow, you give yourself better chance at reproducibility if you follow existing community standards that have been standards developed at various disciplines. DataLad does not interact with that. So it takes file structure as it is, and the dataset is sort of an overlay on top of that. And a dataset, you would create a dataset with DataLad create, and every time you decide you've made changes and you've evolved your dataset contents, you would run DataLad save to create a next snapshot of the dataset. Now that you have this dataset, you might also want to run some code within the dataset that produces the result, and what you might be interested in is what exactly was that you were running. So what was the command that you entered, what was the version of the code, what was the version of the data, what was the parameterization of the command, and you would do this by through another DataLad command, so DataLad run. And it would create a run record that we will also inspect a little bit later, and it would also get saved in the dataset. So the next thing, when you have this dataset and it's running for you and you kept track of what you've done, the next thing you might want to do is to move this thing somewhere else. You might want to do backups for yourself, you might want to share this with other people. So again, if you've tracked things locally, the next step for you is to take these things elsewhere, and you would again have a command for that, and that would be DataLad push. And finally, when you've moved these things elsewhere, you or somebody else can grab it, and here comes the sort of end goal. So you would try to reproduce, like computationally reproduce this process. So if the things have been tracked, recorded in a machine readable way, then first you can grab a copy of something that has been placed in some place with DataLad clone. And then if there were some run records, you will do DataLad rerun and point it to a record. And then in the end, you can verify whether you get the same output. And in our view, such kind of reproducibility strengthens trust in the results and in the claims that we make based on our research. So finally, the ultimate goal is to make it reusable. So if you have some results, they can be a start of another exploration. So what for you was your output of your project, for somebody else is starting point for the project. And you can make things nicely modular with sub-data sets that use Git modules underneath, and that's the one thing that we want to do today. The other things we will explore a little bit more. So there's that. And now, I think that's enough of the short introduction. We will move to the hands-on session when you will get the chance to try out the basic commands for yourself. And I think the modus operandi for today is that we give you some time to explore the examples at your own pace, and then we will do a recap when we will also talk about what you have seen, what you've done. Right, so there's this tutorial website. Why don't you give an overview of that?
Yeah, so on the website you'll see this exercises menu item, and so we're going to do the part 1, working with data sets. And the structure of this, so this is like a simple notebook. At the beginning of each section there's a table with some commands and a short explanation, and those are the commands that are required to do the exercises that follow. And then there's a bunch of exercises, and below every exercise there's also this expandable box that shows the solution. So if you get stuck, you can also look it up there, so you can kind of make it as hard or as easy for yourself as you want to. And here again is the link and QR code for the website if you haven't accessed that yet. And so I'll start this timer, give you some time to work through the exercises, set up the environment. If there are any questions, either ask them out loud or raise your hand, and we'll be with you to help you. Strange choice. Okay, so I hope you all had some time now to work with the basic functionalities of DataLad. Don't worry if you didn't get through with everything, and the website will remain available after the tutorial, so you can revisit it, and also it's not required for the remainder of the tutorial that you did all the exercises. So now I want to take a moment to go over these functions that you now work with. So we start with cloning a data set, and you may have noticed that this was really fast. So if you do DataLad clone with this URL, it's really fast, and this is because DataLad clone only downloads the symbolic file links, not the actual file contents. It's only when you do DataLad get, for example, with this file. Oh, I have to first move into the directory. It's only when you use DataLad get that the actual file content is being downloaded. And this is really nice and convenient when you're working with large data sets. So I'm used to work with working with neuroimaging data, and you very often get very large data sets. So what can you do when you're working on your notebook and you want to test out some analysis? You can just clone the data set, then you can get like a specific file that you want to test on. You can write your script and run it, and then later on you can do DataLad drop and remove the file content again. And then you can push the results of your script to the original data set and integrate it. And this is very convenient when you're working with large data sets. And so this works because what DataLad does is it manages these file identifiers that uniquely associate each of these symlinks with the file content. So DataLad always knows which file content belongs to which file. And so that means these file identifiers are like very central to what DataLad does. So I want to take a moment to explain a bit about them. So we could see DataLad first and foremost as a software that provides and manages file identifiers. So there are globally unique persistent identifiers, and they're generated without any central issuing service, meaning they're offline, they're portable, they're decentralized, all of these things. And there's essentially two concepts for DataLad. The first concept is a data set, and a data set gets a DataLad dataset ID, and we can find this in each data set. There's a folder called .datalad, and in there's a config file. And if we look at the content of this config file, this contains the dataset ID. And then the other concept that DataLad knows is a file. And so a file is identified by the dataset ID plus the relative path of the file within that dataset. The other important component is the content and the versions of the content. So those are identified by Git checksums. So for a dataset has a Git commit checksums, and files have a Git log checksum as well as a Git annex key. So the Git annex key you saw when you did Git annex info on a specific file. You'll see this key here, which is the Git annex key, and it also tells you whether the file content for this file is present on this machine or not. And so by tracking these unique identifiers, DataLad can also manage files across multiple sources, and that you saw when you did Git annex Git annex where is, and this will show you all the. It will show you all the locations where a given file is stored. So this says here, so this is this file location. There's the origin from where the repo was cloned, and then this was like, I think, the file where I originally created this data set on my machine. So in here you might also see some local copies of someone who worked with that data set that you can't access. So it doesn't mean that each of these locations that appears here is can be accessed currently. It just tells DataLad these are the copies of the data set that DataLad is aware of.
And look, there's more identifiers.
Uh-huh.
When you say DataLad's aware of, DataLad was aware of at the point of cloning, or is it still aware?
Right, so it was at the point. So the question is, are these the locations that existed at the point where the data set was cloned?
Yeah.
Yes, so if I would now create a new copy and someone else would clone from the same origin that we cloned from, they wouldn't see my new copy, right? I would have to push my changes again, and then it would appear there as well.
And in fact, it's aware of the copies that were existed at the moment of publishing the dataset. So Ole could have then erased his copy, and his Git annex would complain to him that maybe first publish the information that the copy is gone, but he could have done it, of course, forcibly, and we wouldn't know. So that's the information that sort of got moved with the dataset the last time you put it there.
So now we can answer the question, what actually is a DataLad dataset? And there's a few different answers you could give to that. On the one hand, it's a container for metadata on the evolution of a collection of files. So the different kinds of data that are relevant here are the content identity. So those are represented by the checksums that we talked about. The content availability, basically the different URLs pointing to the different locations where content is stored, and the provenance of change, so the record that documents who did what at which point in time to the data. DataLad dataset is also simply a directory on your file system that is managed by version control software, meaning it has the similar look and feel of files and folders. You can open it in your Explorer and look through the contents. It's also a Git repository, meaning that anything that is compatible and can handle Git repositories is compatible with DataLad as well. And it's also a Git annex repository, meaning also that any storage service that's supported by Git annex is automatically supported by DataLad as well. And you want to add anything to that? So then we can go to the second set of exercises. Now we're going a bit more into the advanced functionalities, where we'll run some scripts using DataLad and use the tracking information generated by DataLad to rerun these commands and reproduce the findings.
Go ahead.
Yeah, just want to ask, so you're currently using, when we got the data from, was some neuroscience Git-like thing.
Can you repeat?
The website, gin.gno.org.
Right. Yeah, this is one of the services that is supported. So this is a storage service that implements Git and Git annex and is thus supported by DataLad.
Yes, that one is hosted by LMU Munich and available to the German scientific community probably. The service itself runs on a modified version of Gitia, I think, which was a project to create a GitHub-like forge.
So if DataLad, I see, doesn't work with something like Zenodo?
Zenodo is a bit tricky. We will cover the services closer towards the end. But there's quite a few places you can go to. Zenodo itself is a little bit tricky, unless you're happy with just hosting your Git repository, a copy of your Git repository there. So no large content, but this sort of metadata container, you can treat it as any other Git dataset. But putting data in Zenodo, because of how Zenodo works, I think there's no ready solution. There have been some attempts by us.
Mine's turned off.
Maybe for the keen-eyed among you, the dataset ID is none of these locations ID. So dataset ID was created as a random UID when the dataset was created, and every copy of the dataset would have the same dataset ID. Now, these are annex UIDs, which identify locations, and the file can use some different backends. This one says it used MD5, so it's an MD5 sum of a file of that many bytes, and this is the MD5 sum.
Okay.
Is there a way to add your commit message through your editor rather than through a black?
Good question. You can write it in a file and then DataLad save, select the file. So you sort of have to do this step manually, point it to a file. What I usually do is I git commit amend. So you can also use, so because it's git and git annex underneath, you can, in most cases, if not all cases, combine your DataLad commands with git and git annex commands. And perhaps for that reason, it's a workaround, but it was never urgent to open an editor automatically.
I just did that accidentally, without my intent. So I did git commit amend, so that it's okay.
Yeah, that's perfect.
Because I couldn't tell how it interacted.
I like that Python community likes good commit messages.
Well, I just always like the editor, so very Why did you go for save rather than add?
Why save rather than add? I think it's a fairly early decision to skip the staging area. So the idea was to simplify, and the DataLad save without an argument just adds all and saves. And you can still save by selecting the files as part of the save step instead of staging and then saving.
I guess if you would call it DataLad add, it might be a bit confusing because people might think it would do staging rather than staging and committing in one step.
Maybe it's me.
Electrically charged.
So I'm thinking, like, I've been working on a paper where I was running a lot of experiments using a slurm cluster. So can I actually, would I be able to use DataLad in this situation where what I was doing was calling my Python file with a configuration, and then this is dispatched to the slurm cluster that runs all everything, and then at the end I get my log file summarized. Can I do this with DataLad? Would it be possible?
Yes, so I think it's one of the places where it starts to shine really. So my colleagues published a few years ago a paper titled Fairly Big, where they show our preferred way of partitioning an analysis. So it's basically a workflow where each of your jobs clones an entire dataset, just gets the big part, that's quick, creates a new branch, gets data for a single subject, for us it's human subjects, but for a single unit of analysis, runs it, commits it, and pushes it back to the original storage, and then when all your jobs completed, you come back and merge everything into one. So this way you end up with this branching out and then coming together, and you can still, you have the thing very granular, so you can grab your laptop and rerun something that was done by a single job. So that's our prepared way of thinking about it. There is also a recent development. Some people who are working with Slurm decided that that's already a lot of work for you to do the orchestration, and created an extension that's Slurm specific, but gives you a command that sort of does this thing where it schedules the jobs for you. Does that answer your question?
Yes, I think I will come to you later. I'm very interested into this because some of the issues that they had when I was working on this would already have like fixed by DataLad, so it's like more in detail.
Okay, I'm happy to talk.
There's also a nice tutorial in the DataLad handbook on exactly this approach of using a cluster and cloning the data set for each job and then merging them back. That's pretty detailed.
There's also a whole tutorial that comes with the article.
Oh, nice.
Exercise 7. It seems that you have to put the flags before the command you're running. If you do the other way around, it doesn't work.
I'd say it depends on the command.
The run command is really fussy about where it executes.
But for the run command, yes, we sort of set you up in a situation where you do have to use these flags.
So it complains that the Python if there's an executable flag.
Sorry?
We do DataLad run. I effectively did a typo and put the parameters in one place. But it actually complains that the Python script that's trying to run doesn't exist as opposed to so in other words, it's everything.
Okay. Yeah.
That's not a problem with your code, I'm just
I agree it can seem fussy at times, but we'll take a look at that. Alright, how are we looking at time?
I think we could take another 5 minutes because we're pretty good on time to work with the exercises, or we go on with the material. So maybe we can just do a quick vote by hand sign. So who would like to spend more time
We need
on
more
the
time. More time is needed.
for the exercises? Yeah. Then we'll do like another 5 minutes or so before we go on.
Does DataLad have its own like log
You have to use git.
It just writes to the git log. I don't think there is a separate log, or is there?
No, the run record is in the git log as part of the commit message.
Right.
And then spoiler alert, git annex maintains its own branch that's sort of unrelated in terms of commits for its own information.
I think it'd be quite nice if you're using one tool, you don't have to switch git command, then that command. Like, even just an alias, DataLad log.
Right. You're saying like an alias that's called like DataLad log that opens the git log?
Yeah, the question was, or comment was that it would be nice if you wouldn't have to think whether it's a DataLad command or a git command that you need to run. Copy that.
How to unstage changes if we haven't saved something but we want to move it back?
How does what change?
How to unstage those changes or restore maybe?
Well, restore, I think you just use the git command,
Okay.
so you do like a git reset.
Okay.
If you, or are you saying if you haven't saved the changes?
Yes,
yet?
unsave. Let's say I change something in code
Yeah.
and I want to restore it so it doesn't
Oh
go
yeah,
in
so
here.
it would be just a git restore, yeah.
Okay, thank you.
Should do it, yeah.
Thank you.
Yeah, that's actually a good question. Is there like a general data-led development philosophy of like when you make like your own data-led command versus when you teach people to use the git and git annex commands?
I think in this one the rationale has always been if there's already an existing git command that does that, then why should we duplicate that in terms of semantics?
Why did you go for rerun a commit rather than just when you pass in a commit, it runs it?
Rather than doing what?
So if you're rerunning a commit, you have to explicitly say rerun.
Yeah.
Why not just run?
Run with the commit ID.
Yeah.
Again, an old design decision. I think it's to sort of emphasize the distinction that you are redoing something that you have recorded previously.
Is it when you do a run like because I think what rerun does, it only makes edits to the git log if the content actually changes, right? And run will always write a commit message. Is that the case?
Not really. I
No?
think
Okay.
if your run, for example, doesn't produce any files,
Then it
because
will
you
also
forgot to
not
save
make a
something,
message. Okay.
I think there would still be nothing to commit. Yeah, I agree. It could be like overloaded, run overloaded to do the same thing. I think the distinction felt important enough to make it two commands, and also not. I think in some places DataLad already tries to do too much with one command, and then you have things that depend on parameterization. So I think also there was an attempt to disambiguate that, so run doesn't have scenes and rerun does. Okay, I think I will move on to the recap for this part. I will first do select exercises. So I think that we've confronted you for a moment with the regular saving, whenever you add something by hand, and also experiencing the idea of unlocking that I will comment on later. The most important part here was this, so where I would run DataLad run. And I would also want to do this, yes. So I want to run a command. So my command is Python code/aggregate data. And I'm giving it two extra things. I'm saying explicitly what are my inputs and what are my outputs. And this thing has double purpose. One is that I'm explicitly declaring my data dependencies for this step. The other thing is, now that DataLad knows about these data dependencies, it can also act on these files that I've indicated in some specific way. It has something to do with this unlock that you have been doing before. So I do this, and it acts. It tells us making sure inputs are available. So this is the consequence of specifying DataLad, specifying minus input. So you don't have to manually get the files. It would get the files by the fact of you specifying input. The outputs, you don't have to run unlock. Should that be needed, it unlocks for you. And then it sees then it runs the command, it says modification check follows, and if there is something that's new that appeared in your dataset, it is reported here below that it was added, saved. By the way, this might be a good moment to point out DataLad. Each command has DataLad run has short help with -h, that's just the invocation, and the -- help is the long help, where you have the entire description and examples and explanation of the parameters. So I know some of these things by heart, not all of them, but there's a way to check them. Right, so I executed DataLad run, so my Git log now has a new commit that was created by DataLad. It could have had a message that I specified, or it could say DataLad run command. It says DataLad run command, and then there is this machine-generated block that says cut here, paste here, and it records things like the exact command that was run, the dataset ID in which it was running, the inputs and the outputs that we have explicitly provided, and I think that's just the exit code of the command. And this is the information that rerun acts on. Right, so we've seen this in action, and you, I hope, had a chance to experience this firsthand. Let's talk a little bit about what happened there.
I think you have to click on the presentation once and then press F for the full screen view. Like click on the iframe where the presentation is in, and then if you press F, it should go.
Perfect, thank you. So first of all, there's two mechanisms at play. The files are getting tracked either by Git or by Git Annex, and this is a matter of your choice. This is done through configuration one way or another. So you get to have a say whether the files should be handled by Git or by Git Annex. By default, all files will be handled by Git Annex, but now what does it mean? So first of all, in all cases, Git will store your dataset history, so essentially the commit messages and the run records that you or DataLad create. It will also store all files and content that was committed into Git, and this is useful with code and generally with text files, because that's what Git is good at. And it will store information about file identity and availability of annexed files. So Git annex. So if you go to man page of Git, the first line it says Git a stupid content tracker, and one line analogous description of Git annex would be that Git annex makes Git a stupid file identity and availability metadata tracker. So git annex takes away the file content and only gives some things to Git. So if we tell git annex that it should handle a specific file, then in the annex of the repository, you will have the contents of the annex files that will be organized in a way git annex wants to organize them, and Git would only get file identity and availability information, either in the branch you're working on or in the git annex branch that git annex maintains for itself. In more detail, Git and git annex handle files differently. This has some practical implication. First of all, and you've seen this before, files that are in Git are downloaded during clone, and annex contents are retrieved on demand when you run get. So this is useful, for example, when you want to distribute your code and some example data. So you don't commit example data to your Git repository because you don't want people to wait for them to download, or they only want to check out your code. Second, when you are running DataLad safe, annex contents, so files that were selected for tracking with git annex, are hashed. So git annex performs checksumming of these files, moves the actual file into git annex objects using this checksum as part of the name, and in place of the file, it puts a symbolic link to this git annex object. So your path now syncs to this specific versioned, content-based versioned thing in git annex objects. And the only thing that Git sees then is the symlink. So the content identity, but not the content. So this is small things, keeps your Git repository small. And because we're storing files as these objects whose name is linked to their content, then the content needs to be locked, so write protected, against accidentally modifying them, so the content is no longer true to the name. Meanwhile, the files that are stored in Git are modifiable directly, so they don't get locked, while annex files need to be write protected. And that's where comes unlock, which makes a copy of the file, removes the write protection from the copy.
I think one configuration that is often quite useful is to configure it in a way so that the small text files are not annexed, because you may not always want to unlock your scripts if you want to make some edits, but you maybe don't want to have the write protection on there.
Yes, usually yes, but there's also no one hard rule. So for example, if you have plenty of text files, you also might want to leave them out of the Git repository. If your text file contains metadata that is identifying information because you're working with human subjects, you might also want to leave them out, so you're distributing the Git tracked part broadly, but you're controlling who gets the annex contents, in this case probably also text files that you have kept somewhere under lock and key. Right. So we've had this locking and we had these symbolic links. Unfortunately, on Windows, symbolic links and permissions do not work the same way. It's not to say they do not work at all, but simplifying that they do not work in the same way. So git annex decides you are working with so-called crippled file system, and under these conditions, it operates in something that's called adjusted unlocked mode. Sounds scary, but again, the practical implications are also a bit of complications, are quite simple. So your file contents are duplicated. So one copy is kept in these git annex objects, and that's the one to keep safe. And the other copy is in your work tree actually that you can edit. So you don't need to do unlocking. You are always having these files unlocked, which is a trade-off. You sacrifice disk space to get some ease of modification. And on Windows, annexed files are not symbolic links, they are pointer files, which are basically the same information. So it's a text file that says /annex/objects and followed by the key that we have seen before. To do this adjusted unlocked mode, git annex uses adjusted branches. What does it mean? You have your main branch that commits have been aggregated, like snapshot this, snapshot that, snapshot change this, change that, and every time Gitanex, when you are in the repository, Gitanex creates one more commit that says adjusted. So does this adjusting business, makes copies of the file, and you're on a branch that's called adjusted main. But when you run DataLad save the next time, Gitanex makes sure to not commit your adjustments, only commit the contents to the underlying branch. This means you are one commit ahead always, and this means git log is a little bit confusing, and you might have issues in some use cases related with nesting or with not being careful enough during git reset hard. But in the end, Gitanex takes away a lot of need to worry about it by always knowing when to adjust and not to adjust. And we can look this, so I'm on Windows, but actually running on Ubuntu here. We also see this data set after the operations. If I do git log here, and this is on Windows, this is in adjusted mode, so we can see the last thing here is run command, and that's where origin master ends. But I am currently not on origin, not on master. I am on master unlocked, which has one more change on top of this, and this is entering the Gitanex adjusted branch. A little caveat that makes things a little bit less nice on Windows, but still keeps them working. And this is again how Gitanex does this. And maybe the last thing, we have 3.
Yeah.
So I told you things go into Git, get symlink into Git annex objects. And there you go, there's some sort of internal structure, but in the end you go down to the identifiers and your files in the worktree point symlink to these objects. So for most, if not all software, it's perfectly transparent. Everything just works.
The complete history is there of the evolution of the files?
Yes.
Only the differences between the files?
No, the files get stored in the annex by their entirety. So if you make a small change to an annex file, it's a different checksum, therefore a different
You will create a copy, right, in the object?
Sorry?
You will create a copy.
Yes, you will create a copy. And more often than not, that's useful because that gives you the ability to go back. If things get out of hand, Gitanex is also, you can tell Gitanex to drop some keys or show you unused, so you can prune this thing to only the things that you have in your worktree. So you can interact with this, but by default you would have one copy every time the file changes. Of course, this means in some cases, if you have the same file in multiple places in your worktree, you're actually deduplicating because it's all pointing to the same object. Like if your worktree has the exactly same file in several folders.
How does it work, the duplication
file? So again, what you see in the worktree is what is in your worktree is a symlink to the content. So if your I don't know, files before something.jpg and files after something.jpg are actually the same picture, you're only storing one copy of that picture.
Yeah, so here the timer kind of got messed up, but we have now like 10 minutes for the third part of the exercises. In there, the first section will go over how to create a local copy of a DataLad dataset. And then the second section is supposed to be kind of a bonus where we show you how to use Gin, that service that we also used for the dataset, to deploy the dataset online. But this will probably be too much for now because you first have to create your account and create access tokens and so on. But it's there for you to follow up on after the workshop. So I think now 10 minutes, and then we have 10 more minutes for review and questions. Can I go to tab completion? Is there a way to turn tab completion? Because it doesn't give me anything here, so install.
There's a
Pencil operating system effect.
There's a question of whether there is step completion for DataLad, and it doesn't come with DataLad. I think we used to have a script that adds it on top, that you'd have to run and then you would have completion for DataLad commands. I'm not sure whether it still works today, but it might. And yes, this is something we would like to have built in. So at some point, somewhere on our roadmap, there is also an overhaul of the command line API. So maybe not the syntax of the commands to not break it, but the way it operates internally. So you can tab complete, for example.
It's like this tutorial is referring to data set that doesn't exist. It's sort of funny order. It's not a problem. I think that's my question. Listing simple.
Let me check what doesn't exist.
Are you saying in the bonus section with the...
Part 3, creating backups.
Yeah, and which exercise?
Just one.
The data set is the penguins thing.
Oh yeah, this is supposed to be run inside the penguins data set that we cloned.
Might be something simple. Make it look like
I can't remember which command it was, but before we had here, origin, and also another thing.
Where it's
There was a previous command we ran where we had like 3 things. That's the last one doing it too.
Oh yeah, this was, I think that this was the git annex where it showed
Yeah,
3
yeah,
things.
yeah. So let's go. We know 2 siblings. One of them is here, and we ask where is this file, and it has
Yeah, that's what
the files that aren't siblings. There's 2 ways or 3 ways to answer that. The high level is that siblings are things we can interact with. So we can right now clone / fetch / get from or push to. And queries are things that are known to exist, but we can't immediately act on them. So the git annex answer would be that these things might need to be enabled first. So enabling might involve, for example, you providing some credentials to some cloud storage. And if they're not enabled, they wouldn't show up in the siblings, and they wouldn't also be attempted to be contacted.
If we add a new sibling, we have to pass this URL, so, and the path can be relative or it has to be absolute.
It can be relative.
Okay.
Should
Thank
work.
you. And because I see that later on DataLad siblings, it is even displaying it as a relative, yeah?
It might.
Because the example is like from the root folder, but I added it on relative path like .. /something, and it is displaying among siblings that the path is .. /something. So if we add it as relative, it is also, I think, displayed as relative, yeah?
I see.
But it was added
I
successfully.
wonder if it would look if it would. Yeah, if you add it, and then if you add it as an absolute path, it would be displayed as an absolute path.
I'm not sure, to be honest.
Yeah, me neither.
Just ask the, if we can read the language.
Both should work.
Yeah, we can add another one maybe.
Yeah.
We can add a second sibling with the same path, or it will complain about it.
With the same path? No, I guess you would, but you could create a new folder, like another bare Git repo and add this. Yeah, you can have as many siblings as you want.
Thank you.
When we are creating the sibling, like in exercise 3, we need to be inside penguins. The penguins.
Yes, right. We didn't write it, sorry about that. I think most, if not all, are require you to be in the datasets.
Right, yeah.
By default, most things are working directory sensitive, and if you are not explicit, it would usually default to the working directory where you can.
Yeah, because if you do it from outside, it would complain that there is no dataset.
Right.
So at the risk of spoiling, you can create the bare repository from anywhere, but when you're adding a sibling, you're adding a sibling to a dataset, so you need to be in the dataset's working directory. In the dataset with your working directory.
I get error message in both directories. So see if I go there, it says refers to unable to check out. Because I took just let it. I see click out and I see click in.
So warning is okay.
Yeah.
So if your comments that are not taken, which branch you want to check out at home, it defaults to your preferred, and it doesn't take the preferred one. So it's just no problem.
Okay.
So this is also what I'm seeing. It's
Because it's in install, I just installed the Git, brand new Git and everything is main before.
so I would check the status.
Yeah, that's right. Yes. So I made the backup and it's actually strange. Backup also.
Have you considered like progress bar or something? The long command.
Which month?
Well, for example, adding a sibling took quite a long time, and I was like, is this actually good? Which hasn't happened.
The bash, right? So if I remove this backup, just delete the directory or do I need to?
If you want to delete this backup, you remove this directory. It would be also good to inform your installing the repository the information that it's no longer available, and you would do this by git access mechanism dead. No, that's a mark something dead.
So I just delete this, as I say, rm dash on.
Yes, you on macOS you
Yeah.
probably need to maybe need to change the permissions to write recursive plus R plus W. So okay, so you can move this backup. The information will still be.
I don't know what permission it has.
You would have to probably look at the GitHub extension.
Yeah, not only the directory.
I guess I don't say
Okay.
about the progress bars, many comments have them, but sometimes they need improvement, I admit. I think for siblings ads, it doesn't, because the expectation wasn't that it would. It usually is fast, sometimes it might not be.
It's been slow for me.
Okay, so we're almost at the end of our tutorial. Let's go quickly over those exercises. So here, what we did is we used this bare Git repository as a push target. So I just quickly wanted to explain about that. A bare Git repository means there is no work tree, meaning that the contents that would normally be inside the .git folder are in the directory itself. And the reason to use this is that just simply if you don't have a work tree, then pushes can't break the work tree. So this is suited for storing on a server and collaborating on with others. And if there's also git annex on the machine that stores this git repo, then it can store git annexed contents. So, and this means it's a good default setting for a git and git annex aware service. So another question is, what is actually the content that's being pushed? So you might have seen that. So when let's first initialize the bare repository. So I'm doing it in my home directory here. Oh, there is already one. And then we can add this as a sibling with the siblings add, and we can name it anything, and we can give it a URL, and then it should be added. So then if we say DataLad siblings, we should see this now as a new one, the backup. So let's look at the content of this new sibling. And so if we look at the tree, we'll see this is just basically the content of a Git repo. Oh, it looks like I already pushed.
It has an X object because you used an existing one.
Yeah. So normally what you would see the first time is you wouldn't see the annex objects here. You would just see this folder objects, which contains the Git blobs. And then actually you'll have to push twice, because on the first push, the annex is initialized on the Git repo, and then on the second push is actually where the contents are being transferred, and this is then where you'll see this annex object tree in the repo, which is where the file content is stored. And important to note, and this is what you see here, is that only so this is what I just explained, so that Git push acts only on the contents that are present in this current copy of the dataset, which is why in here we only see the JPEG files present. So the other data content, for example, the CSV tables, which I didn't download here, they're not present in this copy. So if you want to transfer a specific file, you first have to do DataLad get and then DataLad push to make sure that content is copied as well. So what about storage services that are...
Maybe a short introduction. Why did we suggest you use Git bare repository? This has been for a long time in Git, but is probably, in my opinion, not mainstream. This is something that you would use, for example, if you are doing backup on that's an option to use for a backup on a hard drive. That's an option to do backup on some sort of your home lab if you don't want to be bothered with the front end or for a Git repository. But this also simulates an interaction with a Git forge that can also also understands Git annex. So you would add it as a sibling, and you would push it, and there's a chance that there would be something like a bare Git repository underneath.
So then what about storage services that are non-Git aware? So in Git annex, there's a concept called special remotes that can be created with Git annex init remote. And on the Git annex website, there's a list of all the different kinds of remotes that are supported. So it's a pretty long list. And there's also instructions for using specific services. For example, you can use Amazon S3, you can use Google Drive, and so on. So there's a number of different storage services that can be used with GitNX. And you can have multiple special remotes, so you can have as many remotes as you want. And there's also fine-grained configuration available. For example, you can configure the preferred content of a remote. For example, you could say, well, this remote only wants to store JPEG files. And then when you would push to that remote, you would only transfer the content of those files. There's also a parameter called numCopies that determines how many copies of each file NX wants to keep. So if you would do DataLad drop, NX will first check how many copies of that data are available across all the different repositories that it knows about. And then if dropping that data would drop you below the numCopies required, then it would throw an error. So then you can't drop it unless you use the force flag. And so per default this is 1, but you could also set it to a higher number if you want some additional security. And so then which services are supported by DataLad? Well, since DataLad uses GitNX, all the services that are supported by GitNX are supported by DataLad per default. And then there's also additional services where there's like a dedicated DataLad extension that allows you to use the service. There's also, for example, OpenNeuro, which is a now pretty established service in the neuroscience community that actually uses DataLad on the back end. OSF, for example, there's an extension for DataLad. Gin is the service that we use to host this Penguins dataset, and this is also what the bonus exercises go over. So the bonus section here goes over how to host the dataset on Gin. This is mostly some configuration related to Gin, just in the web UI. Once it is configured, the command is actually exactly the same. So you just do a DataLad siblings add, and just as a URL instead of the path that we used before for the bare git repo, now it's the URL to the Gin repository. So other than that, adding it works exactly the same. And so yeah, with these options, you'll have a lot of different options available to host your data. You'll also see GitHub is here. So for example, one thing you can also do is you can create a sibling on GitHub. And since GitHub does not support Git Annex, you can't just transfer the annexed contents, but you could have the annexed contents somewhere else, and you can just transfer your Git repo to GitHub, and then you can use this to share it with others. And then if they DataLad clone from GitHub, the resulting repo will be aware of the other siblings where they can get the data from, and so you can just do DataLad clone, DataLad get from GitHub, and DataLad will automatically fetch the data from the corresponding location. And now it's 5.
You left the best one for the end. So the logo next to GitHub is for JO. For JO is a project that we are under the impression has a lot of traction going on currently. So So again, it's a piece of software that you can self-host and gives you a Git forge, so something that works similarly to GitHub, but it's your own. And it shares similar lineage to Gin, also some related to GitHub, but doesn't matter. It has a lot of traction going on now. And there is also a fork of 4JO that adds Git Annex support. It's called 4JO Annex.io. It's also maintained at Forschungszentrum Jülich. And it also gives you this 2-in-1, so Git plus Annex in the same service. We have been using it for our lab for quite a few months already, and we are very, very impressed with what it does.
Yeah, so if you want to have some more questions or just want to chat, we'll be around for the rest of the conference. And yeah, thank you for your attention.
Thank you.
So this geo service that you are using, can you share the URL or it's in the slides?
Which service?
It was in the slides?
For Geo?
It's in the slides. Yeah, geo.
Yep, it's so I think we made sure to put some further readings in the modules. So there would be some links for things that. So surely these were just initial impressions. So there are pointers to where to look next if that's the part that got you intrigued. For jo.org would be the. Can you type FORGEJO?
Like this?
Or no?
No? With a G?
Like Forge
It's in the slides, in the last section.
Oh.
and then JO. And then you would have to do some searching for JO Annexio. It would bring you to a Codeberg page of the project. By the way, Codeberg is the organization that maintains ForJO.
Is there a DataLad handbook tutorial on ForJO yet?
Probably. Nobody left, so let's open the handbook. Beyond certain infrastructure, probably. Not yet. Not yet. No chapter, but it's mentioned throughout, so I can't recommend enough. Handbook.datalab.org. You don't have to read it start to finish, but it's structured so that you can jump into chapters and read more about what you are interested in. I think so.
Yeah.
Thank you.
Yeah, thank you.
What did you use to do the slides for the QMB format?
It's a Quarto.
Quarter, okay.
Yeah, it's pretty nice. You can do a lot of things with it.
I'm not in the Jupyter book, so.
Yeah, I think it does a lot of. I haven't worked with Jupyter Book, but I think it's the goals are pretty similar.
Yeah, they're just switching tools. Yeah, they have tools 2.0 alpha or beta now out, and they're switching a lot of things. So they're switching to Mist. They use Mist already, but they rebuilt it. So
What is Mist?
it's an extension of Markdown.
Okay.
They give a lot of it's an extension of Markdown for some papers, so they give pretty much everything research text can do.
Okay, yeah. The QMD.
Images and tables and all that.
Yeah, the QMD is basically also just an extended Markdown.
Yeah, it looks very similar.
Yeah.
All this special commands with those.
Right.
I'm working on institution, so
Yeah, nice.
Because I used LaTeX, but now they support types. I just wrote the research report with LaTeX. I spent so much time getting those small, this one, the appendix, screws everything up. And then I slammed it, and then it compiles ages, and then the
LaTeX is
and then I went to say Control C, and it doesn't stop. It doesn't stop. I have to kill the process and I have to delete all
The compiler, you mean? Doesn't stop?
No, if you can, very often if you Control C, it keeps going.
Yeah.
You have to put it in the background and you kill the background process because you don't get it to stop. It keeps going.
And also the errors are really hard to trace back.
You always have to do binary search and say, okay,
There's a problem. I just okay. I comment out everything until I find the place.
I have a question.
Yeah.
So do I can subscribe for the community event tomorrow? To the social event?
Yes. Yeah. Go to the website. No. I'm happy about that. It's always a good thing if there's
website,
people
but there's no
participating.
place for
Yeah, one thing I was wondering.
in the
Which
team.
is
So
easy
I can't answer any question though why a certain command is.
Oh yeah, no. That's just an interesting kind of.
No, I get that. I'm wondering that myself often when I use
tickets,
software.
yeah.
So I was just remembering like
one ticket here right
in terms of like you mentioned at the end you could have your text
So okay.
track somewhere, as in your non-data somewhere.
I can pay by
Right.
the website,
And
no?
so and that's why I asked about that.
Right.
So at the moment, are you familiar with Pooch?
No.
It
Yeah,
seems
probably.
like basically like a way less smart.
Okay.
I was looking at that. And so the reason why I use this is I have this code base which basically has a bit of large data. And so I have my repo which is just the code, and then I have
So you're making a clone,
essentially
you're
this.
with it, and you're throwing the clone. You're pushing your additions to the storage, and you're throwing it away. So the code exists in this template.
You know something you touch for a while.
And then you also not pushing directly to main, you're pushing on you first creating branch. Why? Well, because from the logical perspective, all individual jobs start from the same starting point.
There's another
Multiple branches, each progress one pointer, and as long as you're not conflicting with those, you can do the tokus merges. Each branch, then two branches.
So essentially, the moment my workflow is I have this, which is literally just some data file,
Yeah.
like binary files.
Yeah.
But I didn't want to store it.
Yeah.
So Git, which has the code,
I
and then the
think
data.
that's the.
And then what
that's
Pooch
what
does,
and
it's
also
fast.
because again, for us,
It essentially it just basically
basically
caches it locally, so it checks does the user already have it, and if not, it'll download them as and when you call them. So if you're only using one of the data files, it'll only download that one,
Yeah.
and otherwise it'll pull them one by one.
And how does it work? Like it,
I don't know how it works under the hood,
okay.
but I was wondering whether I could like, because Pooch is not that well maintained, it
Uh-huh.
seems, and so I was wondering if I could replace it
Yeah.
with DataLad.
So one thing I have done, for example, is that I used like OSF just to dump the data and then just have the repo on Git where you can see everything and then you can just like clone it and just do a DataLad clone and DataLad get and it will then download the data from OSF.
Yeah. I guess like the advantage of this is like I don't want no one uses my code, but in the theory they did.
Right.
I don't want them to have to be calling command. So the advantage of this is like when they run some command the first time,
Yeah, so
we're like, oh, okay, you need that data, and
Yeah.
get it from you. And then if they run it again on the same system, you've already got that data.
Yeah.
It just uses it.
yeah, so this I always check like if you maybe can search for the DataLad handbook. That's usually my resource to look for. And there's whenever I want to check how something works in DataLad, and there should be like a section in there. So the first part is kind of the basics and so on, and then there's like here like third-party infrastructure where there's like tutorials on different services.
Yeah, so like for example the S3, you could have your Git repo,
Right.
data stored in S3.
Right, exactly. I think for if you make the sibling on GitHub, there's like a specific command. There's like DataLad create sibling GitHub or something, because it kind of works a bit differently, I think, than just the regular Git repositories. But yeah, exactly. So you could have different storage locations, and then I think when you do try to get data, like DataLad or GitNX will just try all the different sources that it has listed to check if the data can be fetched from there.
Yeah, so if you have like the GitHub one, you're not saying that you store the data.
No. You just store your Git repo, but you'll have the metadata there, right? And in the metadata, you'll have the record of the different copies of that data set that are somewhere. And then you'll try to access them. Some can't be accessed if it's like a local copy on a computer that you're not connected to, but then others might be like URLs, like web URLs that can be loaded.
Okay, so why, yeah, with that in mind, why would, I don't know.
Why you would?
If I was in S3 work, why wouldn't it work? Like in my use case.
I don't know. You have to ask Michael. I think he said something about how the Zenodo file system works internally. I have no idea.
Yeah, because it just seems like
yeah.
You know, as far as I'm aware,
yeah,
these just have a URL.
Yeah,
which they do appear to.
Unused.
But yeah, I guess maybe there might be a subtle.
I think it has to be like somehow compatible with storing the annexed content, right? So you have to store the content there in a way that Git annex knows where it is, right? With the checksums and the tree structure and so on. And I don't know, for some reason that is not trivial. Yeah, I'm not sure. That's a bad question. I'm just a user.
Okay.
Any commit that points to
no,
the
it's cool.
object,
It's
but the object is not removed by Git branch.
Yeah, I don't know how Zenodo works.
Yeah, I've used it before also to generate like DOIs for code.
Yeah,
but I've never used it for data storage.
Yeah, this is the one project I have, and it's worked quite well.
What are you doing?
So this is more just it's not really code I use now. It's code I made during my PhD.
Okay.
But I kind of keep it maintained just so that if ever I apply for jobs, someone's like, show me something done.
Yeah.
There you go. And then every time I learn something new, like a cool Python thing, whatever, I often will try it.
Yeah.
But yeah, it doesn't really matter what it is, but essentially there's like some big, a bunch of eigenvalues, eigenvectors are computed for something that are stored in Zenodo because they're so time consuming.
Okay.
So the point is like the user can still generate the stuff.
Yeah.
Now, if you're calling a certain parameters I haven't already saved, then it will compute the given matrices manually.
Okay.
But if you there's a subset of them, it will like pick up.
Yeah.
So,
yeah, I think it's nice if you have it like arranged in a way where you can just give it to someone and they can like rerun it.
yeah, exactly. That's the thing. Like, but it's fun. I know when you use it. Like, it's such a niche area.
Yeah.
No one really touches it.
I mean, maybe for someone from the same lab or whatever, it could be useful.
Yeah. But yeah, the fun with like active projects is quite hard to like introduce a new something niche.
And
Yeah.
we just have implementation that's in DataLad. So that you can go in 7-zip the objects, and then when you retrieve it would unzip it as needed. That's one thing to do. And other thing, DataLad generally operates with this notion of special remotes. It has remotes that we can interact with. This one has special remotes that we can interact with, and special remote is less of a place and more of a protocol, like how do I get or store an object from the place. And I've heard people who wrote for themselves an implementation that for pushing, so say DataLad DataNext push to the remote, and then it first compresses the file and then it moves it to place B, and for retrieve you can guess what it does.
Yeah, that makes a lot of sense. Because I have a lot of those different experiments with running models and sometimes it's true. Okay. Thank you very much.
Yeah, no problem.
Okay. The beginning of your presentation.
No worries.
Something was with this microphone, yeah.
I think throughout the earlier tutorials, one is slightly buzzing, but only sometimes. It also didn't.
Yeah, no, it was fine.
Cause any problems.
Okay. Well, it worked mostly.
Yeah, definitely.
That's
not mine. No.
So thank you very much, Barry. Thank you.
Bye.
Have a nice day. Okej, cześć.
A już nie musisz tu siedzieć.
Nie wiem, projektor wyłączyłem, a kamery nie potrafię chyba.
A ten, w sensie dalej się wyświetla to, tak?
Znaczy, nie wiem, ale to jest podświetlone.
Nie, ale w sensie nie chodzi o to, żeby włączyć cały setup, tylko... A, teraz się nie chce włączyć projektu.
A teraz wyłączyłem, już się nie włączy, tak? A, włączy się już. Włączy się.
Nie musi się włączyć tylko ten. No dobra, startuję. Coś czerwoną słuchawką się to oznacza. Trzeba przytrzymać.